Okay, now I wrote this down because we love it so much, but it turns out as soon as I turned the camera off and thought for a second, that's not going to work. But we got to see why. Okay, we need to see why this kind of gets messed up, and it's because weird things happen as you approach zero. Okay, so well, fx is the square root of y over 2x. Fy is the square root of x over 2y, right? I mean, you've done these derivatives, so we don't need to. Okay, so fx equals 0. If y equals 0, but x doesn't equal 0, because if y and x were both 0, you'd have an expression here that's undefined. Okay? Then you'd have to consider what happens as you approach 0, 0 along different paths. Something we haven't talked a lot about, but will a week from today. Okay?
Yeah, I saw that in the homework. I didn't really know what to do. I was going to read my book, but
yeah, I accidentally assigned some of that, but it was good for you to think about it. Okay. Okay. So we want to say that 0, 0 is critical point. But x can't be 0 and y can't be 0. So we got to go to alternatives, which is basically thinking very carefully about what the graph of this thing looks like in the neighborhood of 0, 0.
so take the limit as it approaches.
Well, you can't. Well, you can take the limit along different paths, or you can consider a parallelepiped, okay, or a circle surrounding the point 0, 0, tiny circle or tiny parallelepiped with the 0, 0 kind of in the middle, okay, and think about what that looks like. It can be instructive, okay. But you see, one thing we find about the square root of x, y, it's not even defined if x and y have opposite signs.
So it's only defined in...
So it's only defined in the first and third quadrants. And talking about what happens then at 0, 0 gets a little bit complicated, okay? So you got to do kind of what I said, but then you got to confine your domain, and then things don't always make sense at 0, 0 because you can't approach 0, 0 from certain directions, okay? So you got to worry about that, okay? So we're back to parallelepipeds, or even preferably little circles, but cylinders, okay? But cylinders aren't as instructive about these partial derivatives as parallelepipeds are, at least until we go into partial derivatives with respect to like r and theta in polar coordinates. So we don't want to talk about that right now, okay? It's not that hard once you get this down.